Okay, we are going to take a look at problem number 1 that you all worked. And I want to start by looking at a couple of different things. First, as we look at this question, it says consider the parabola y is equal to x squared. So that is the parent function x squared. It is the parabola. We're going to draw that in just a second. And you have to do 3 things. You have to show that the line through the point 3, -7 with a slope of -2 is tangent to the parabola. Find another line through that point that's tangent to the parabola, and then answer the question if there's a third line going through that point. So let's look at just the first part. If you want to determine if a line is tangent to a parabola at a given point, the first thing you need to do is find the equation for the line. So the equation formula, we'll start with part A here. The equation for a formula, or the equation for a line, y over y1 over x minus x1 is equal to m. And in this case, you're given the slope and you're given a point. So you would put into that y minus a -7, which is y plus 7, over x minus 3 is equal to -2. Now, let's put that in slope-intercept format just because it'll be easier to handle. Y is equal to -7 minus 2 times x minus 3. Y is equal to -7 minus 2x plus 6. Y is equal to -2x minus 1. So we now have our equation for the line. So let's see if that line actually intersects with the parabola. So we have the line, y is equal to -2x minus 1. We have the parabola, y is equal to x squared. If we want to find if or where they intersect, set them equal to each other. X squared is equal to minus 2x minus 1. And then let's solve that equation. Whatever the answer is, that's where they intersect. And because it is a line intersecting a parabola, it can intersect at 0, 1, or 2 points. So let's see what we get. X squared plus 2x plus 1 is equal to 0. X plus 1 times x plus 1 is equal to 0. So when x is -1, we have an intersection between the line and the parabola. And that is, in fact, the first point that you would get showing that the line and the parabola intersect at x equals 1. Now, if they intersect at x equals 1, that's great. We have a place where they intersect. Now, how do you show that it's tangent to the parabola? Actually, a very easy and fast way to do it, to show that something is tangent to a parabola, instantaneous slope is what tangent is. So if you have y is equal to x squared, y prime has to equal 2x. And 2x would be the slope at any given point. Well, the point that we have is x is equal to -1. Y prime is equal to 2 times -1, which is -2. So the slope, the instantaneous slope of the parabola x squared when x is -1, well, let's start. The slope is 2x at any given point x. So the instantaneous slope is when y prime is equal to 2 times -1 or -2. So what you've shown here is your point. Pick up that marker. You have shown that at the point 3, -7, slope of -2, you come up with this equation for the line. When you set the line equal to the parabola, you find that they intersect at -1. The slope along the parabola is 2x at any x value. When x is -1, the slope is -2. Okay, so that is part A. Now let's go on to part B. And as we go on to part B, what we're supposed to do here is find any place, or see if there's another place where the parabola intersects. So the first thing I'm going to do is just do a quick sketch so that I can understand. Here's our parabola. Y is equal to x squared, and then we have a point down here at 3, -7. So the first line that we found went something like that. And what we want to find is there another line? And if there is, what is that line? And it's going to look something like this. So logic would tell us that there are going to be two. So we just need to algebraically show why that is the case. So going back to part one, the slope for any line that's going to be tangent to the parabola is going to be 2x for any particular x value. So we want to find the tangent line in green. So we're going to go back to point slope form. And with point slope form, we have a point, we know what the slope is, so let's go ahead and see if that gets us any place. So we'll come up here, y plus 7 over x minus 3 is going to equal 2x, because that's the slope at any given x point. Remember, we're trying to find the x up here, whatever that might be. And I have not drawn it to scale, so don't pay any attention to the fact that it looks like it might be x equals 5 or 6 or something. I haven't done that. So we can again say y is equal to -7 plus 2x times x minus 3. Let's go ahead and simplify that. Y is equal to -7 plus 2x squared minus 6x. So y is going to equal -7 plus 2x squared minus 6x. I just wrote that, didn't I? It's been a long day. Okay, so that is effectively the equation for where the line might intersect where the slope is 2x. So we need to satisfy this equation, and we need to satisfy y is equal to x squared. So we're going to do what we did for the last problem, set them equal to each other. X squared is equal to 2x squared minus 6x minus 7. That's what I meant to do the last time, was organize the terms in order. So if I subtract x squared from each side, I'm going to get x squared minus 6x minus 7 is equal to 0. And then if I factor that, the x minus plus 7, 1. So when x is equal to 7 or x is equal to -1, those are the 2 points where you can draw a line that goes through 3, -7 that intersects the parabola. So if it intersects the parabola at x equals 7, what is the slope at that point x equals 7? Well, the slope is going to be 2x, which will be 14. So what we can do from here is we can say y plus 7 over x minus 3 is equal to 14. Y is equal to -7 plus 14 x minus 3. Y is equal to -7 plus 14x minus 42. So y is equal to 14x minus 49. Okay, so now that we've showed all of our work, let me go back and highlight where all of the points show up for this problem. Okay, the first point that you get for this is coming up with the equation for the line. Hang on. this equation right here, coming up with that, knowing to put 2x in for your slope and coming up with that line. That's where you get your first point. Second point is right there, setting x squared equal to that equation. Next point is coming up with the slope is 14. And the fourth point for this problem is coming up with the equation for the second line. Okay, now the third part that you had to answer is there a third line through 3, -7 that is tangent to the parabola? Justify your answer. Okay, if we go back to the previous part that we worked, part B, what you see here is a whole lot of work to show that there are two lines that are tangent. So let me just do a quick little highlight of what I'm talking about here. If you look at this diagram that we have drawn, from the diagram you could say, well, yep, it's true, there are only two ways that you can intersect, but of course it's not that easy. You have to justify your answer algebraically, and it's actually pretty straightforward because you came up with the equation x squared is equal to 2x minus 6 minus 7, and I'll go ahead and highlight that. You came up with this equation, right? Which gave you this equation. So that is the only equation where lines can intersect the parabola, the x values that satisfy that. So it's pretty straightforward. All you have to do is come up here and say the quick answer is no. And your justification is all solutions must meet x squared minus 6x minus 7 is equal to 0. Because that is a second degree polynomial, there are only two solutions. So that is the short answer to a very long question. So you get 2 points for this. 1 point is for saying no, and the second point is for saying that the solutions have to meet that algebraic requirement. You can't just use logic. Well, I suppose you could, but you'd have to write a paragraph to do that. But what they're really looking for here is all solutions have to satisfy the quadratic equation.